It's pretty wild when you think about it, how some of the most useful things in our modern world can also be some of the most destructive. We're going to talk about a whole group of chemicals that are basically living a double life, part hero, part villain. Today, we're pulling back the curtain on these chemical chameleons, the haloalkanes and haloarenes.
So, on the one hand, they're like these unsung heroes of convenience. Think about the cold air coming from your fridge or your AC. Yep, that's them. The stuff that pushes the spray out of an aerosol can? That's them too. For years and years, these compounds, especially the ones called CFCs, just made our lives way easier. But, and this is the big twist, those exact same CFCs that were keeping our food fresh were also silently floating up into the atmosphere and just wrecking the place. They were literally eating away at the Earth's protective ozone layer. A total hero in our homes, but a massive villain for the planet.
So how can one type of chemical be this incredible tool and this huge environmental threat at the same time? Well, that's the big question we're going to tackle. In this explainer, we're going to break down the chemistry behind this really fascinating and kind of problematic family of compounds.
All right, so to really get their whole Jekyll and Hyde thing, we've got to understand what they are on a chemical level. It's time to get properly introduced to the compounds at the heart of this story.
At their core, the idea is actually surprisingly simple. You just start with a basic organic compound, made of carbon and hydrogen. Then you just swap out one or more of those hydrogen atoms for a halogen atom. And by halogen, we mean fluorine, chlorine, bromine, or iodine. That one little swap completely changes the chemical's whole identity. And this slide right here shows the two main families perfectly. If you look on the left, you've got your haloalkanes. See how the halogen is attached to a straight or branched chain of carbons? Now look to the right. Those are haloarenes. Here, the halogen is hooked onto a super stable, circular thing called an aromatic ring. It's the same basic idea, but believe me, that difference in the carbon backbone makes a huge difference in how they act. Now, chemists love to keep things organized, and they basically classify these in two main ways. First, by the carbon chain, just like we saw. Is it a straight line or a ring? And second, by how many halogens are attached. If it's just one, they call it a monohaloalkane. Got two? It's a dihaloalkane. And if you've got a bunch of them, like in chloroform, it gets called a polyhaloalkane. Simple as that. So these things don't just pop up out of thin air, right? Next up, let's get into their origin story, how chemists actually build them in a lab.
There are a few really clever ways to do this, but they mostly fall into three main buckets. Chemists can start with something like an alcohol and just replace its OH group with a halogen. Or they can take a plain old hydrocarbon and kind of force a halogen onto it. And there's even a third way, called halide exchange, where they can swap an existing halogen for a different one. It lets them make exactly the compound they need.
Okay, so now we know what they are and how they're made. But what gives them their chemical superpower? What is it that makes them so reactive, so incredibly useful, and ultimately so dangerous? The entire story, everything, their usefulness in making new things and their power to destroy, it all boils down to one single really important feature of their structure.
And here it is. This is the secret sauce. It's all about that carbon-halogen bond. See, halogen atoms are what we call electronegative, which is just a fancy way of saying they are electron greedy. They pull the electrons in that bond toward themselves, which leaves the carbon atom feeling a little bit positive and makes it a prime target, super vulnerable to being attacked by other molecules.
And get this, not all of these bonds are the same strength. Just like the quote says, as you go down the periodic table from fluorine to iodine, that bond with carbon gets weaker and weaker. The carbon-iodine bond, it's the weakest of all, which means it's the easiest one to break, and that makes it the most reactive. This variety is exactly what gives them their chemical superpowers.
So the bottom line is, this weak polar bond is like a chemical springboard for three really powerful kinds of reactions. In what's called substitution, the halogen just gets swapped out for something else. In elimination, it gets removed completely to create a new bond. And when you react them with metals, you can make these incredibly useful tools for chemists, like Grignard reagents, which are like essential chemical Legos for building bigger, more complicated molecules. Okay, let's wrap this all up. We've looked at their structure, how they're made, and the secret to what makes them tick. It's time to put them on the stand and weigh all the evidence.
And here you have it, the chemical double life, right there in black and white. On the left, you've got this amazing list of uses: refrigerants, heavy-duty solvents, anesthetics, antiseptics, even life-saving medicines. But then you look to the right and you see the dark side. Those very same compounds are behind ozone depletion and all sorts of environmental pollution. You know, the damage, especially from CFCs, got so bad that the world literally had to do something. More than 190 countries came together and signed international agreements like the Montreal Protocol to phase out making and using these ozone-killing substances. It was actually a pretty amazing moment of global cooperation for the environment.
And that leaves us with a huge question for the future, right? We now understand the source of their power, that unique carbon-halogen bond. So the big challenge for chemists today is how do we use that power for good, to make new materials, new medicines, but design them so they don't cause the same environmental damage. The story of haloalkanes isn't over. It's just starting a new and hopefully much, much safer chapter.